Well, thank you everybody for joining us today, for joining me to talk a little bit about Intelitek and our online learning. It says Intelitek LMS, but what we're going to be talking about is, yes, our LMS, our learning management system, but how we use that to deliver our products and services online, and how we can do a blended engineering/advanced manufacturing program online. If you notice on the bottom, we have Yaskawa, Cognex, and Siemens listed there. And we are actually the exclusive resellers for Yaskawa to education, as well as Cognex vision systems to education. And there's several different products from Siemens. Our Robot Expert, which does, their Robot Expert, I should say, that does quite a bit with simulations, where I can simulate a factory with different types of robots in different types of situations. So I can integrate a robot with a Haas CNC mill or a Mazak CNC mill and basically put a conveyor together and do different things, and then do what-if type scenarios with it. So there's lots of different things there that we can do with Siemens. Everything that Intelitek does, we wrap curriculum around. So everything that I'll be talking about today has curriculum. So we've been around, Intelitek has been around for 38 years. Obviously, when we first started, we just made hardware, CNC machines, small CNC machines, as well as robotics. And over the years, we've developed curriculum and have brought everything online. So when we talk about Intelitek, it's a full product line. We have the lab hardware and curriculum, but we take that and we do simulation with it, with software, and simulate the hardware. So when I talk about simulation, we're using the same control that runs the hardware, and then we're adding some simulation to it. So when I'm simulating something online, I'm using the same control that runs the robot or that runs the piece of CNC equipment or PLC or whatever. Everything we've done is managed through our LearnMate management system. In fact, it's now cloud-based. We've had it cloud-based for 5 or 6 years now. And we can also integrate our learning management system with yours. So if you're using Canvas or Blackboard or something like that, when the student logs into Canvas or Blackboard, they would see our courses versus having to have a separate learning management system to log into. So we can integrate our learning management system with a school system that you might have in place today. So it's a single login type of activity. Of course, tied into that, we've always had summer programs for professional development, but we also are now offering online professional development, as well as we can come to you and do professional development and service development. Along with Peyton Group, who is our distributor in California. They do quite a bit of training as well. They know our products very well, and they've been doing quite a bit of training as well. So what I wanted to show you today, this is on the right-hand side is a picture of our CNC mill. That's our bench mill 6100. This is our smallest mill that we offer. We also have a floor standing model of this. And on the left-hand side is our bench mill 6100, which is the simulated version of it. And you can see it looks very much the same, and it works the same way as if I was standing in front of the machine. We are a sponsor of several different contests at Skills USA. And why I wanted to talk about this is here on the right-hand side, you can see the bench mill 6000. It's now the 6100, so this is an older picture. You can see the student is cutting a part here. So it's a team of 3 students. One student is a CAD operator, and we've set it up to mimic an engineering firm or a company, where the engineering piece of it, they take the blueprint, bring it into CAD, that the student redraws the picture, or brings it into CAD, outputs that to the CAM operator, and that's this student over here, where he's bringing it into something called CNC motion, where he can actually machine the part, set up the tooling, make sure the tool offsets are proper, and set up all of that. and machine the part virtually before he hands it off to the student, so he can verify the output of the CAM software, whether it's Mastercam, SurfCam. We work with all of those, and verify the operation of that before he hands it off to the student that's machining the part. So it's really a team effort, a team of 3 students. And I really wanted to show you this part of it so we can do 100% verification. So when I'm doing that, this is what it looks like. I'm going to go ahead and bring over. In fact, let's go ahead and just open. So here is the machine. You can see the shield is open. And so a student would have this software at home or on the computers, on their computer. And as you can see here, I can close the shield. And when I zoom in, just get this out of the way here. And I have full control. This is our jog control. This is our interface. We also have a FANUC 21 interface with this as well, but we like to start the students off assuming no CNC knowledge. So this is a very friendly Windows interface. And I can zoom in. Here's my X and Y. And I can, as you can see, I basically drove the tool into the stock without turning on the spindle. And if I turn on the spindle, you can actually see I'm actually cutting a tool path. And then if I come out, if I drive the tool into the vise, I've broken another end mill. So you can see this is the same interface. So if I remove this interface, if I have the physical machine, this is what I'm looking at. But since I'm doing simulation, I'm going to add this simulation window. And so things like, if I want to insert another tool, I'm going to say insert a tool from station number 2, it says the machine must be home first. So before I can actually do any type of automation with the machine, it's forcing me to home the machine, just like I was at the physical machine itself. So we're trying to, we mimic the hardware itself and make the student go through everything they would have to go through when they're sitting at the machine. So basically what it just did is on the Z-axis, it hit the limit switch up here. It's now setting the Y, it's hitting the limit switch. So here on the actual position, you can actually see the machine, that's machine home right here. And absolute and relative is my reference position for the stock. And it does have a cheat tool, if you will. I can actually go and tell it to find a corner. And that would be one of the differences with the actual machine. You would actually have to find the corner and find the center of the tool by touching off on each side and the top of the stock to find the actual center of the end mill itself, to find that 0. And when I go to say set position, it says I haven't configured the ATC yet. So I'm going to say, do you want to perform that action? So what I'm going to do is say tools, configure the ATC. And what it's asking me is it needs to verify what tool is in the spindle. And so again, like I was there, it has to verify everything. So we'll set position. That is the origin. And what I started to do before, let's just see what happens if I say now to tell it to, let's just go ahead and insert tool number 2. So you can actually just see it's doing a simple manual tool change. And if I did a tool change in the code, it would do that as well. And let's just do that real quick again. Let's just put tool number 1 back in there. And as you can see, I can zoom in and zoom out from any different angle and watch the different operations that are happening. So this is tool 1, 2, 3, and 4. So it has a 4-station tool changer. I can configure the system to match whatever hardware that I have with the system. So let's just verify. I'm going to go ahead, touch off the top corner, verify. I'm set at 0. And let's go ahead and put in a new piece of stock and cut apart. And here you can see it's doing something very simple. It's just cutting a circle.
Can you watch the commands during this operation if you wanted?
You can see them. You can see the line that it's going through down below here, the different lines that it's going through. Now, we do have a CAD, a very simple CAD design program with this. That's built into it. It's up here, it's called design. And if I go to CAD, and you saw, I'm just going to do a very simple, what I like about this is, I'll just do a rectangle. And I'm just going to engrave it. It's just going to say, select the stock, do the selection, hit next. The final depth is 1/10. The depth increment is half of that, so it's going to make 2 passes when I'm making a cut. It's 7/10 of an inch above the stock when it does its rapid. So I'm just going to go ahead and if I close this and just do file, let's just do, there it is. So it brought it in. What I just wanted to show you there is how quickly I can do a very simple, get the student to do something very simple. I just basically did a square, and as you can see there, and you can get the student to using the software and using the piece of equipment very quickly. I'm just going to go ahead and minimize this, and let's take a look at the curriculum associated with this. This is our LearnMate curriculum, and I'm going to go ahead and hit login. And we have lots of different curriculum: safety, mechanical measurement, quality control, CNC milling. And here you can see the first activity we have with this is introduction in safety, using the motion control software, mounting the workpiece, tooling, reference positions. And as you can see, this is grayed out. As an instructor, I can grade and control what the student sees. So this wouldn't even show up to a student. It would be blank until I made it available to the students. At the very end, there's a post-test. That's a 40-question test. And if I just go ahead, let's take a quick peek at what it looks like. So here, of course, we're going to start off with introduction and safety. And we assume no knowledge. So this is taking the student from not knowing anything about CNC, what is it, what is a mill, some of the different safety involved, the different objectives, a little bit of history behind it, some of the different applications. So the student, lots of different links throughout the curriculum, giving them a little bit of insight what it is. I'm just going to go ahead. I was just touching on activity 1, just going to jump out of that. And in activity 2, this is going to teach the students about the control software. And as I navigate through this, it's going to teach me how to use that control software. And right here, when I click here, it says click here to run the software. So when I click here, it's actually going to open up the CNC control software. It's going to launch it and license it. And that's going to bring up this software and license it and bring it to the appropriate screen, bring in the appropriate setup to match what the curriculum is taking the students through. So this is, it's called CNC Motion. It is an application. So to run this application, it does require Microsoft Windows. So it would require a full PC. The curriculum itself is HTML5, which could run on a Chromebook, but the application itself does require a PC. So that's what this student was doing here. Coming back to this, the student is operating the machine. This student is setting up that part so he can hand it off to the student so he'll be ready to go. And as I mentioned, we always, in all of our hardware, we always start off with assuming no knowledge, what is CNC, what is a mill, talk about safety and all of that. Here we're looking at, this is robotics and automation technology. This is the second contest we sponsor at Skills USA. And this is our ER4U robot. We offer several different robots. As I mentioned, we're a distributor for Yaskawa Motoman, the industrial robotics as well. But currently we use our ER4U in this contest. And it isn't just a robotics contest. It's actually, here's the robot, you need to understand how to program it, but there's lots of I/O with this. So we have a PLC over here, Siemens PLC. Here we have different types of sensors, parts feeder, a stack light, that there's a terminal strip on the side, so they have to hardwire the terminal strip into the PLC and into the controller. When they're programming this, they have to understand all the different inputs and outputs and the sensors and all of that. This contest is actually sponsored by Nissan Motor Corp, and the judges are from Nissan Motor Corp. And what they do is they hand the students basically the contest material, and it says, solve this particular problem. And what it is there's blocks, there's metal and plastic blocks. They have to figure out which one's metal, which one's plastic, which ones have a hole, and which ones don't have a hole. And they have to go through that whole process and document how they're going to wire it all together, present that to the judges. They give them a thumbs up, and then they actually implement it. Nissan has hired over 25 students off this Skills USA floor. And so we're very proud of that a lot of these students, so some of them every year will get hired by Nissan Motor Corp. So just like we do with CNC, introduction to robotics, what is a robot, a little bit of history about robotics, of course, how they work. There's lots of different types of robots out there, some of the different components. So we're going to take the students through all of that. And when we're looking at robotics, we do quite a bit with simulation. In fact, here we have some of the different educational robots we offer. This is called a fenceless cart. So it has an area scanner underneath it that if you walk right up to it and it's running, not just manually moving it, but running it, running the program, it will stop. In fact, if you're 6 feet away, it will be fully functional. And when you get closer than 3 feet, it will slow down to 50%. Then you get within that 3 feet, it will stop. But you can manually move it with the teach pendant. This is what our software looks like. So again, we're able to, just going to go ahead and open a project. This is, let's just take a quick peek at what a pick and place program looks like. So this is a simple robot, a Yaskawa Motoman industrial robot. We actually support, this is what they call an MHJF, and we support a GP8 and several different other robots as well now. And here we have jog control, and we have a joint coordinate. So the individual joints, here's one joint right here, I call it the waist, and here's a second joint. So here we have, I can move the waist left and right, and then here I can bend at the waist, and then here is my shoulder. I can bend my shoulder, then I can twist or rotate my shoulder. So each one of those is considered, this is a 6-axis robot, So each one of these joints is considered an axis. And then here we have rotating the shoulder. And then this is the wrist, which with a pitch, if you will. And then I can rotate the wrist as well. And then when I get into Cartesian coordinates, similar to what you saw with the CNC mill, now we're just dealing with X, Y, and Z. So now you can see it's going to move all the different joints to keep the end of the gripper, or the TCP, the technical term is at the tool center position, in a perfectly vertical motion. So here we go. See, it's moving all the joints appropriately. And if I keep driving it, and I'll drive it into the table, the collision has been detected. And then of course, if I move it along the y-axis, you can see it's doing the same thing until it hits its limit. So we can teach how to program the robot, how to have robot movement, everything here. In fact, we can take it to the next level. And let's just take a look at, now I just jumped over a bunch of curriculum. What I mean by that is I was just doing basic robot programming. Now we have a robot on a linear slide base. Here you can see, so now I'm actually expanding the work envelope by 1.8 meters. So now the robot can run along the slide base. It's integrated with a mill, it's integrated with a lathe. We got a couple of different parts feeders. We got an assembly station. We can have a vision station for inspection after it makes the parts. And, but I can do all the same movement. So now what we can do with our software is not only teach individual robot, you saw our CNC motion, teach individual CNC machines, but now this is a system, a flexible manufacturing system, that we're bringing it all together and teaching it as a system. And I'm just going to go ahead and stop that. And you can see here is a system similar to that. Here's one of our larger CNC mills with a GP8 robot with you barely see it here. There's a camera. So you can see we can do quite a bit with simulation, curriculum and simulation, teach it all online. And then I can come into the lab. You can see we have full access to this machine. I can learn about CNC machining, but also learn about robotics, and then bring it all together. So I can do it virtually, and then I can do it with the hands-on as well. We have full certification on the robotics for Yaskawa MotoMan. We've worked with Yaskawa to provide online, with our online curriculum plus hands-on to provide certification. And just a real quick view. This is actually a school, Shasta High School. You can see it in motion here. You can see the integration we did with the pneumatics. So now the robot's going to be integrated with the CNC machine. So what's really interesting with this is when the students are learning all about robotics and how to integrate a robot with a CNC mill, you can actually control things from either our FMS software, or I can control from the robot. I can tell it to open the shield. I can tell it to open the vise. So you can have this system control, but from the robot's perspective, if you will. So the robot is actually controlling things versus having it done individually. And of course, there's a safety shield here, there's sensors in here. So the robot will not go in there until it detects that the sensors are. So you can look at this as a flexible manufacturing system, but we're teaching a lot with here. Here's some of the controller for the linear slide base. As far as when you talk about mechatronics, you have the pneumatics, the device, the shield opener, the pneumatics that have been added on here. So that it's sort of bringing everything together as a system. And it's a great opportunity for students to learn here as on a system, something like this. Now let's take this even further. And here we have a small factory with individual FMS systems. And on both of these systems, we can teach Industry 4.0. And what do I mean by Industry 4.0? I'm going to back up all the way here. When we're looking at this robotic station, the students have hardwired this robotic station in, right? There's a common, there's red, green, blue light. So they have to bring power in, and it's being controlled by the PLC, open and closed relays to bring power in there. But I can make this a smart device, take those wires off, just plug in power and add an Ethernet cable. So now it's a smart device, and all I need to do is control it through the PLC or the robot controller through an Ethernet type connection. And that's when we're starting to talk about Industry 4.0, where your devices are now becoming smarter, where I don't have to hardwire things to it. Now I'm plugged into it through an Ethernet connection. It has its own power supply, and I can control it from a PLC or from the robot controller through the program. If this goes bad, I take it out like the TV set nowadays. You replace a TV set versus having it repaired. I can quickly, in industry, it's all about keeping the production line moving and be able to repair things very quickly. So instead of having to rewire everything, I can quickly just replace it, plug in an Ethernet connection, and away I go. So that's what we talk about Industry 4.0, and this is taking it to the next level, if you will, where we have a parts feeder and the different stations making different parts, where it has an ERP system where I can tell I want to make 3 widgets and 2 yo-yos. And based on the raw material it takes, it will actually take the raw materials off the conveyor, machine the parts, and do an assembly and inspection here. So before we get to that level, one of the things I wanted to quickly show you folks is our foundation skills program. With this, this is the core of the curriculum. And when we look at it, we talk about our foundation skills in manufacturing, safety becomes a big part of that. What is safety? All the different aspects of safety. And let's just take a quick peek. I'm just going to jump back to my dashboard and click on safety fundamentals. And here we have things such as introduction to OSHA, safety in the workplace, personal protective equipment, PPE, which we're always hearing about today, safety procedures and production team training and responsibilities. So this gives a great overview of safety, and a lot of the programs we put in place use this as a starting point. And if I take a look at introduction to OSHA, I'm going to say, do you want to resume where I left off? I'm just going to say no to start at the beginning. So here you can see what is OSHA. Now, with all of our curriculum, I can be doing what we're doing today and presenting the students to it this way, or it can be self-paced. So it's giving a nice background about the Triangle Shirtwaist Company in New York City and how many people were died and what happened there. And so it gives a great history about safety and why OSHA was started. And if you folks are interested in viewing this, I'd be happy to set up an account and let you view it. But as part of this, as the students go through this curriculum, there's a review test. This is anywhere from, this is probably a 15-question test that covers all of the materials that they covered in this area. Just like here, there's a review test that covers all of the material covered here. And the students would just click on it. And let's just take a quick preview. Didn't do so well on the last. So this is an 11-question test. And the way this works is we shuffle the answers. So if I was looking at the person next to me, or I called my friend and say, okay, let's start with question number 1, it actually shuffles the answers, and question 1 for me would be different. It could be question number 10 for my friend. So we shuffle the questions and we shuffle the answers within the questions as well. And so this happens to be a multiple choice. So it's either A, B, C, or D. So, and as you can see, this is where I am as I navigate down through. And I'm just going to go through. I'm going to just say finish attempt. You can see this is what I've done, what I haven't answered. I can return to the attempt or submit it all. And since I'm a teacher, I can actually see how well I did. Now, this is something as an instructor, I can control who gets to see the answer. So I can also control how many times they can take this test. So if everyone has taken the test twice, I'll let them see the answers, but not until everybody in the class has taken the test. So that's just a little bit about what that looks like. And that's called safety fundamentals. The other one I mentioned, we have mechanical measurement quality control, takes the students through, well, let's just take a quick peek. You can see accuracy, precision, and measurement tools, units of measurement, fractions, decimals, and rounding, scaled measurement tools. And what's nice about this is I can actually do a segment on safety and then do a little bit on mechanical measurement control, quality control, so I can mix up the materials in a class. So I don't have to have them just do measurement or just do safety. I can mix it up for them. And here you can see vernier, dial, and scale calipers. And again, the students gotta navigate their way through it. And all this curriculum is HTML5, so the curriculum itself can be run on a Chromebook. So this curriculum doesn't use any additional software like I was with robotics and CNC. So this whole curriculum could be run on a Chromebook. And so that's a little bit about mechanical measurement quality control. Other areas we do have are hand tools, power tools, process control, CAD. And if I jump down into Site Home, you can kind of see all the different topic areas that we have to offer. So everything is accessible online. The majority of the curriculum can be fully run on a Chromebook. The only pieces of it that are when you look at CNC or robotics or PLCs, we do require an extra piece of software, but the curriculum itself can be run on a Chromebook. So this is the Foundations program that I mentioned here. It's the core to going off to doing the other things, whether it's electrical systems, fluid power, PLCs, robotics, CNC machining. So you can see it all builds on itself. FMS is what I was showing you, where we've integrated robot and a CNC machine together. And that's the foundation skills program. We do quite a bit with industrial maintenance as well. And one of the things we learned with industrial maintenance after working with industry is don't use banana plugs. Because one of the biggest problems they have in industry is, one is they don't use banana plugs. Two is the students, when they get a job, they're going to over tighten and over screw, strip the screws because they're using too large of a screwdriver. They don't know how to strip wire and terminate the wire properly from left to right, and how to basically make the connections properly. So industry told us that make sure you're using terminal strips so that they learn how to basically strip wire and make a connection, because that's where most of the problems reside with an open or a short, those types of things. And everything we've done, all the job tasks that we do in our job master systems and everything that we do are derived from industry. So we work with industry to understand how to wire in a power supply, how to program a robot, and we walk through all the different steps involved with the different job tasks, right from the plant floor. As you saw, safety practices meet OSHA standards. Wiring practices meet OSHA standards. So these are some of the different things that we also offer. Electrical series, mechanical, maintenance cells. Some of the different labs we have. But everything that we do, we wrap in curriculum. And the majority of the things we do, we have a simulation for it as well. This is our maintenance cell. We have hundreds of these around the country, thousands of these around the country, I should say. This is something that we give work orders. The students build it as a kit of parts. So they have to use hand tools, power tools. They're cutting conduit, they're bending conduit, doing this assembly. Once it's built, they can swap out, use different types of PLCs based on what's local to them, what industry is requiring, whether it's a Siemens or an Allen Bradley. They can swap out, reprogram them, put on different motors, a DC drive, an AC servo drive. This is a conveyor belt system here that we're looking at, where there's a parts feeder that does it serves the parts to the conveyor, and it does a paint, bake, cool operation. We can do fault insertion with that as well. So we have a broad range of products that we offer. Lots of different training type systems that we have to offer. And everything we do here is simulated. You saw the CNC motion software, you saw a little bit of the RoboCell, but we also do PLC. So we have different HMIs to have different situations for the students to learn about programming, pneumatics and hydraulics. What we like about when we are able to simulate pneumatics, so they're going to wire the different components together virtually before they do the lab piece. But what's nice about this is they actually see the cross-sectional view of the components. So when they're looking at the physical hardware, they don't get to see that. So that's what's nice when we're looking at the fluid power, whether it's pneumatics or hydraulics. So some of the different labs. And thank you, everybody. It looks like we're about to run out of time, but I wanted to thank everybody for their time today. And if you have any questions, I have some time. Feel free to ask. And please take my phone number and email if you'd like to have a free demo or trial access to any of the curriculum. We'd be happy to set that up and let you try it out.
There are a couple questions in the chat you might consider taking a look at.
Okay. I apologize, I'm having a hard time getting there. I don't see it.
If you stop sharing screen, it would be along
Okay.
your bottom.
Okay. There we go. Thank you. Okay. So hopefully they enjoyed the robotics competition. You said it's the most intense experience they've had. That's great to hear. I hope that's a positive. That I take that as a positive experience. That's fantastic. Are there different questions or just in a different order, or are there more related questions on the test bank? There is a test bank. Typically it's 40 questions, and we shuffle from those 40 questions. There's the quizzes that are anywhere from 3 to 10 questions, but you have the ability to change out the questions. But typically it's the same 40 questions that we offer. The hard part about that is when you start changing out, if you give one student a certain set of 40 questions and another student different questions, is that fair? But typically they are the same, but they can be changed out. There can be more test questions added to the test bank. Absolutely. In fact, I'm glad you mentioned that, because one of the things I failed to mention is the fact that you can add PowerPoints to the PowerPoints of the system that could be downloaded by the students. You can edit the content. You can insert your own questions, all of that. So it is a full LMS system that can be integrated to your own LMS as well. So if you're using Canvas or Moodle or one of those others, it can be integrated with those as well. So you started school, Julio. You start school tomorrow. Wow, that's fantastic. You're in a country area. So if you're interested, give me an email. I'd be happy to set you up for 60 days to let you log into the content and review it. If you're going to be teaching on the scoreboard, I'd be happy to do that. But give me a call and or talk to Chris with Peyton Group, and he can get you in touch with me. I'd be happy to set you up for you, not your students, but let you go through the content and go through it. And I'd be happy to do that and let you try it out. Okay. Well, great. Well, thank you very much, everybody. Any other questions?